What tools do you need to learn, how that world looks like, how different it is from conventional product development is all we'll just look at it. Okay. So to start with, I'll keep it very simple. If you go to ChatGPT or if you go to Perplexity or if you go to Claude AI and just type, give me in one sentence what is a DevOps is. If you just type this, it will tell you that it is some practices which help software development and IT operations do high quality software production and efficiently. Okay. Maybe this doesn't ring bell for us primarily because we don't know what is meant by integrating development, IT operations, what is high quality, what is continuously, what is effective is something very premature for students at your background, like in third year or second year, to understand. Okay. But in this session, we'll just explore how this world looks like, what people will do in general, and where this DevOps will fit in over time. Okay. I'll just typically use a whiteboard for everybody's understanding. Okay. I'll try to keep it very simple. So, to start with, did anybody of you all actually worked in team projects so far in your college? If yes, just type yes. Okay. Like team of three or four. Did you ever worked on any project in your class or in as part of any other course? No. Maybe did you? I think you might have at least submitted an individual project by yourself, like an individual contributor. If yes, just type yes. Okay. So imagine if you are in your campus and if you opted a course and if there are four people who are doing a project. Okay. Typical students, let's assume you are building some hospital management system. Okay. You typically create a application for doctor, you create a small UI for nurse, you create a patient database, right? You store it in the background. You will have a UI, you will have a DB, and you will have a small integration layer in between. So maybe one person will take care of UI, the other person will take care of the DB, one person might take care of the integration, and the last guy who doesn't like to code or is not interested to code or he has fear of coding might end up writing some documentation or draw some class diagrams, etc. Right? Typically, that would happen if you write projects in team. Okay. But when you deploy the project on your final exam or during the presentation, when your advisor is looking at judging the project, you will run it in localhost, right? And you show that project to your the examiner, get some marks, and you qualify, right? But before reaching the local host, you typically deploy some products, right? For DB, you might use MySQL. For middleware, maybe you will use Flask or you will use some Tomcat, Apache Tomcat server to host the application. For web UI, you might have used some HTML, CSS, and JavaScript, right? There are certain tools you will use. Let's call them as technology stack. Okay. Imagine you use this technology stack to build your local project so that you can get some marks. Okay. Now extrapolate this project in your NIT campus to a large company like Amazon. Okay. Where it has more than 1 lakh developers, maybe some 50,000 teams or like 50,000, 5,000 teams, okay, who continuously build certain projects, use some tech stack. They will be so busy in building these projects and deploying them, they would might even think of managing the projects which they use as part of the tech stack, right? For example, there is a team one which uses MySQL 4.9. There could be a team 2 which uses MySQL 5.1. There could be another team which might be using MySQL 6.0, some version, okay, to do so that they can build their products and deliver to their customers. Like how these four people ended up deploying their tech stack by themselves, large teams which work in large companies typically don't deploy their products by themselves, okay? They depend on a particular team called dev operations, okay? DevOps or developer operations is actually a team which consists of bunch of people who help this large population of developers, testers, product managers, project managers, architects, which can be web architect or DB architect, solution architect, everybody in an IT company, like a DB architect, database engineer, data engineer, everybody in the company depend on the dev operations team. What does this dev operations team do in general? Okay, they take care of the ownership of entire technology stack. They decide where to write the code, what code needs to be written, when to write the code, how to write the code. All these rules are typically played by the DevOps teams. Okay, let's look at where. Imagine you completed your BTech and ended up in a company called LinkedIn. As a fresher, you were asked to fix a bug. Okay, you will open the code. For example, there's a bug in an HTML. You open the HTML file and fixes the color. Let's assume they asked you to change the color from red to blue. So maybe you do BG color is equal to blue and you fixed it. Okay. You can't just go and deploy the changes directly on production so that customer can see the change. No, this is not allowed. There will be a DevOps team who will come and they will stop you. They define a process for you to do this bug fix in a certain order. Okay, what is that order? Let's look at that order, a sample order. Okay, they will give you an environment called dev environment, which is only accessible to you. You have to fix it in that environment. Your changes will be moved to another environment called stage, which is like a copy of production where you can deploy the fix and validate the change. This environment is given to another person who is called as tester or a QA. Okay, you are a developer who recently joined. This guy is a QA. This guy tests your fix. If the fix is working as per the suggested change, then it will goes into the production. Okay, so if you look at this transition, the transition of giving a change, which can be a bug or a feature, is actually asked by the DevOps guy to do it in dev first, stage first, production first, production later. Okay. So this chronology of implementing one small bug is managed by the DevOps team. That's why where plays a key role. You can't just deploy it on prod, even if you know the solution. You have to follow the process of where the fix need to be deployed first and then it should go to production based on the chronology defined by them. Then let's look at the what question. Okay. Yeah, you know the bug. You know that in the HTML page, line number 89, I need to change BG color from something to something else. You know this change. Okay. And you fixed it, and you applied the change in dev, applied the change in stage. The QA guy is testing it. But again, the dev guy comes into picture. He tells you, hey, this is not the right way to deploy a fix. I will not allow you to just replace the HTML file. You have to replace all the dependent files linked with the HTML. There could be a JS file, there could be a CSS file, there could be some JSON file which is hooked with this HTML. You have to bundle them and then do the deployment on your dev environment, then stage, then get it tested by the QA, and then release the product to the production. So the DevOps team defines what are the files you are changing. Those files are bundled together. Are they being deployed in right place, right time with right version? Okay, because when you pick up a wrong HTML file, the version could be version 1. You might have made changes, the file version would have become 1.1. Now when you bundle that file, maybe it becomes version 2. Are you deploying v1 again? Are you deploying v1.1? Are you deploying v2? Is something managed by the DevOps guy. So that's why what plays a key role. What files are you changing in the production? Okay. The next item is when. Imagine the QA guy has actually tested it and he said, yeah, the file is good, the code is changed, and he gives a sign off to deploy it on production. But again, the DevOps guy comes into picture and tells you, hey, you can't deploy directly on production. I will define a calendar. I will give you a release calendar. You only have to deploy the changes on this calendar. Okay. Well, how that calendar looks like. So they'll tell all the major changes should go once in a month, maybe on Saturday. All minor changes should go once in a week, maybe on Saturday. So they'll tell that whatever goes in monthly basis, I call it as service pack. Whichever goes in weekly basis, I may call it maintenance pack. Okay, that's why if you go to any product, you will see a multiple versions. If you know C, C++, or Java, they have Java 1.1, 1.2, 1.3. These are nothing but the versions of the product which went in the form of service pack or maintenance pack. Okay. So when to deploy, the DevOps guy will give you a release calendar. Based on that calendar, you're allowed to deploy. Okay. So the complete ownership of your development activity, right from managing the tech stack, where to deploy, where to do the change, what change need to be done, when to do that change, is typically owned by the developer operations. Okay. So that's why a DevOps role plays a key, uh, um, it's a key function in the entire development process. And to answer the last question, how, we need to understand how the engineering teams or a company actually looks like. Okay. Imagine, let's call this guy Sachin. Okay. Sachin is a new guy, new student who finished his uh, um, BTech from NIT Trichy, joined a company called Entity Data. Okay, let's assume. He was awarded a designation software engineer 1. Okay. Now, when Sachin joins the company on first day, he will be given some orientation. Hey, this is your team. This is the company looks like. These are the teams. Person A does this. Person B does this. I'm going to explain you how the teams pan out, so that you'll understand what type of authority does the DevOps team have on respective team members. Okay. The teams typically start with a team called product management. Okay. Product management contains APMs, PMs, who nothing but they define the features of the product. Like if you're using Swiggy, if Swiggy introduces a new feature which surprises you, it is actually ideated by this fellow. Someone in product manager management has created that idea, and they define that idea, and they give that idea to the engineering team. The engineering team contains managers, developers who actually build the solution and then give it to another organization called QA, who basically do the testing. Testing has multiple dimensions. It could be performance testing. How soon the Swiggy app is getting open? Is it responsive? Which typically done by usability testing. If 10,000 people access Swiggy app, will the app runs similarly when compared to 10 people using the app? That's typically taken care by load testing. You have various other forms of testing like performance, unit, load, usability, which is typically owned by the QA org. Okay. Then comes a team called release team. These people are bookkeepers. They keep where the code is. If the code is written by engineering, they bookkeep the code in tools like Git. I think you might have heard about GitHub, right? There are other tools like Bitbucket, Jenkins, etc., where all the code you write, they preserve that code in the Git. The release team who does the bookkeeping will take the code written by the engineering, tested by the QA, and maintain it in the Git. And they'll ensure that they release the product into production based on the release calendar. Okay. In the end, there is a team called implementation. This is the team which will do the implementations for your customer. They will take the installer, run the installer, deploy the product, configure the product for customer, and ensure that they deliver the product to customer. The last team which typically you have is a customer support, who talk to customers on day-to-day basis, understand their issue. If there are any bugs, they will send those bugs to the engineering team, and this cycle continues. Okay. Now, if you carefully observe, every stage of the product, engineering, QA, release, implementation, and customer support, DevOps is always in contact with them. For product management, they will ensure that they have access to relevant databases to do basic queries, UI to do testing, just to see whether the feature they created is working or not, like a beta environment or an alpha environment. Okay. For engineering, they'll give you what we call a boilerplate. Boilerplate is a basic machine which has all the softwares installed for you, so that you can start development on day one. So when Sachin joins entity data, when the IT guy gives him the laptop, the next person Sachin will meet is a DevOps guy. This DevOps guy will help him set up the boilerplate. If he's a data engineer, he give all database tools. If he's a web engineer, he will install all the web tools. If he's a middleware engineer, he'll install all middleware tools and keep his machine ready so that he can become productive. Okay, so that's how the DevOps get in touch with engineering. If you look at the QA team uses a lot of testing tools like HP Load Runner, Test Suite. There are many tools which QA team uses. Like there is another simple tool called Selenium, which is an API testing tool. So all these tools are typically used by QA team to perform their regular jobs. But the access to those tools, setting limits to those tools, enhancing the capacity of those tools is owned by the DevOps team. So if QA team is stuck, they're not productive, they'll go talk to the DevOps. Hey, I need more capacity to my load runner tool. I need more API calls I need from my Selenium machine so that I can do load testing across multiple web nodes. DevOps guy will have to help them. Okay. Then comes the release team. The maintenance of Git system, Bitbucket, source code is typically maintained by these people. All the underlying tools are owned by the DevOps. So if they are not able to release a product based on release calendar, the DevOps will come into picture, help them out, and let their job is done. Okay. The other team like implementation, who talks to customers, deploys the products manually through by running installers. If the installation is failed, if it's not working because of server compatibility, operating system compatibility, hardware compatibility issues, the DevOps teams comes into picture, helps them out, completes the deployment, and onboards the customer on the product. Okay. Lastly, you have customer support team. Imagine a customer calls a customer support complaining that, hey, entity data, I'm using your ATM. I pushed the card into the ATM. I tried to withdraw 5,000, but my card got stuck. The customer support representative will ask which node it is, which ATM it is. Can you reproduce the steps? What's your card number? And he'll go back, uses a simulator to verify if they can reproduce the problem. Now, that simulator support is typically provided by the DevOps team. Okay, so at all these levels, DevOps will touch every team in an organization. They will babysit with tool support, process support, productivity support, so that all the teams in a company can become productive and deliver better products. Okay? That is why they use so many tools at different levels for different teams so that they become a center point for all the teams to address their needs. If you look at the simple screenshot which I try to bring up, this I typically use in a DevOps course for people to introduce what the DevOps team typically do. What is the job role, job description? So because they're touching different teams, right? They're touching product, they're touching engineering, QA, release, implementation, customer support. They own the tools used by all these people at various stages. So they will have admin rights of all these tools, some understanding on how to use these tools at all setup, and they'll ensure that they will give the support to those people if they're stuck with those tools. For example, some new developer like Sachin couldn't write a code and push the changes to a code repository like GitHub. The DevOps team will go and check whether this fellow has an access to GitHub. Does he have access to that repository? Can he write? Can he push the code to production? or can he push the code to a particular repository? Those type of investigations the DevOps team typically do. Okay, so there are variety of tools which a DevOps team needs to know, but they don't need to do everything in single day. They'll start with supporting one team, eventually supporting all the teams over time, and they become a DevOps architect or a DevOps leader. Okay, we look at how the DevOps engineer will progress over time. Okay, in upcoming slides. But to show you how these people fall in, is look at this example. There is a simple timeline which will show some circles in orange, yellow, green, blue, and violet. Okay. So if you observe, the size of the circle tells you the involvement of the DevOps resource in the particular team. Okay. So in the initial phase, when people are doing research, whether to give a feature or not, small proof of concepts, to test a feature or design a feature or ideate, DevOps team will help them to give support to the tools they use. For designers, they'll give designer tool support. For engineers, they'll give engineering tool supports. For QA people, they'll give QA people to support. And during the launch of the product, they give support to the implementation. Okay. So this is the way entire software is typically produced. And without a DevOps engineer, it is very difficult to produce a software these days. Now, you might be thinking, hey, is this something new? Aren't there any DevOps resources since last 20 years, 30 years? Why this is so much craze in these days? Okay. Why we have to learn DevOps, or why DevOps has become more impactful in very recent times? Because even in 1970s, software was produced, 1980s, 2000s, software was being produced all the time. But DevOps became prominent because the way people are producing software is actually changed. Okay. If you have taken software engineering course in your graduation, you might have seen something called waterfall model, right? What I've shown so far is a waterfall model where you typically have a feature, someone designs it and then writes a code and then does a QA and then does a release and does a maintain. Okay, this is typical waterfall model. But there are a variety of other models like spiral or hybrid models where people only do design, partial coding, and they don't even do QA. They'll release a alpha product, which is unQA product. They call it as iteration 1. In the next iteration, they do QA. In next iteration, they deploy. In next iteration, they'll completely change the design. So this is an iterative model. Because there is rise in different product production techniques in software, they badly needed some people like DevOps who can behave like watchmen, or they can behave like a guardian to the entire product development cycle, so that all the teams in the all the teams in the software productions become productive. Okay. So this is what a short glimpse on what a DevOps typically looks like. I'm open to questions before we go ahead on their basic responsibilities. The chat is open. If you have any questions, you can please pose your questions. If there are no questions, then I'll go ahead. Okay. I'll talk about 3 items today. in context. Oh, sorry, what happened to my screen? Yeah, here we go. Yeah, I'll talk about three items today, considering the time. First one is source code. Second one is continuous integration. And continuous delivery. Then I will talk about monitoring and observability. Okay. Source code. So as you see, where is the mouse? Yeah. As you see, people like Sachin, who recently joined an organization, will be surprised to know that if I have to change an HTML, I can't directly do it on prod. I'll have to do it on development environment, which is my boilerplate. Then I need to do it in stage. Then I need to do it in production. Okay. But in first place, he need to access that HTML file, right? There should be some place. So typical source code repositories like Git, they maintain source code in particular variants or versions. Okay. Version 1 repository, version 2, version 3, version 4. If there is a website in version 1, it contains 5 HTML files, 3 JS files, 4 CSS files, and there could be some 2 JSON files. Sachin will be asked to fetch the HTML file from V1. He will use bash commands. Bash is a programming language which will help you to talk to your kernel, okay, your operating system. It also help you to talk to your repos like Git code repositories. Okay, he will use certain operations like pull, merge, get, commit. Okay, these are some operations which he typically uses, so that he can read the source code, make changes, and then publish the code. Okay, so what you see over here is the V1 which Sachin has pulled in, but Sachin has fixed the bug. So his repository will no longer be V1, it will be called as V1.1. Okay, because his code is being read by V1, he made some change. That change will now be applied in V1.1. So if Sachin's code is still defective, V1 is still active. If Sachin codes found to have more changes, they will create another V1.2, or they'll extend this and create V1.1.1. This is what we call source code versioning. Okay, you create versions or copies of your source code so that you can make your code changes on your source code. It is almost similar to like you start writing creating a diagram, or you open a word document, you started writing a word document, you didn't like it, you made a copy of it, you don't want to delete the original version, you made a copy of it, and then started touching that new file and updating that file, and you give it as version 2. Later on you figure out that you need more changes, you don't want to delete the second version, you create a copy of it and then start writing v3 and start writing in that documentation. Similar fundamental, people use source code from one version, fix the code, create subversions, and they finally merge it to a final version called v2, which becomes the latest code. Okay, So unless until Sachin doesn't pushes it to production, this V1's journey will not be moved to V2. So tomorrow, if Dhoni, who is a new developer who comes into the company, will no longer touch V1 code, he will directly go to the V2 code and start fixing his bugs. Okay. So typically, this is our source code is managed and maintained, and this is called source code versioning. Okay. Now let's look at continuous integration and continuous delivery. I'm trying to explain these concepts which we typically do it in a semester length in very short, brief example so that you'll understand glimpse about what DevOps is. Okay. If you look at continuous delivery or continuous integration, there is a team which works on web, which is UI. They work on HTML, CSS. There is a team which works in DB where they work on MySQL, they write SQL queries. Some people work on middleware where they either use Fast API or Flask, like kind of a tool. Now, team 1, team 2, team 3, they are doing development independently, but to release a product, they have to merge their code, right? Otherwise, the final product will not be able to store data because of database team, not able to integrate because of integration team. The UI may not work because of the web team. So the integration is key. If you correlate this versioning with the integration, the web team might be using V2, the DB team might be on V6, the middleware team might be on V7. Now, how do you merge these things and create V8 is what typically a continuous integration is all about. This is a very basic example. If you go deeper, you will get more and more problems, more and more sub problems to understand. This is a very high level understanding on what is continuous integration is. So, in short, you have different teams contributing towards one final product. Different teams build different parts of the product. They are in different version of the product, but when they release the product, they have to release it together, like the front end, back end, middleware have to integrate the product together and release one final version. Now DevOps team will define rules on how to do the continuous integration, what methods you need to rely on, and once you become successful in doing the integration, how do you deliver it? Because the client will not wait. For example, if there is a bug in Swiggy, you ordered a sweet, but you received a biryani, you raised a complaint, the customer support guy tells you that, sir, there is an integration issue. Our continuous integration team fixed the front end, but didn't fix the back end. That's why you ordered a sweet, but in the back end, it got recorded as biryani. So the point is, if you don't integrate better, you will end up in these real world problems. So the continuous integration and continuous delivery of the product will package similar features together so that you don't arrive on a defective product. So this rules for defining integration and delivery are managed by the DevOps team. Okay. The last important item which you need to know in a short, crisp way is called observability. Observability. Okay. You can ask GPT what observability is, but in short, observability tells you whether what is developed by the development team is really exists in that form or not. Like we'll go back to the Swiggy example. If Swiggy changed the logo, if Swiggy changed the logo, it should reflect on all the Swiggy apps. If Swiggy changes the color, it should reflect on all the Swiggy applications. If Swiggy tries to change the way of the ordering, the control flow of the ordering, it should mimic the same way across all the instances of the apps. So the observability is a module which will sense whether the released feature is present across all instances or not. They will review constantly that V8 version 8 of a code is released to the customers. Are they on version 8? Are they on version 8 is something they check. That is why if you observe, the mobile apps send you a push notifications. Hey, there is a new version of an app available. Do you want to update your app? Can you rate my app so that you will be kicked to the app store and get the new version of the app installed? These are all observability tactics which will push you towards the right stable version so that you benefit the right features which are delivered by continuous integration, continuous delivery. So these are main duties of a DevOps team on top of the regular engineering teams, which is visible to our eyes, which is typically visible to any developer. So if you are a Sachin who joined a company like an early developer, or if you're a Dhoni who joined after Sachin, you can see the versioning, you can see how the continuous integration, continuous delivery is done, you can see how observability is maintained, so that for the fact Dhoni or Sachin knows for the fact a right version of the product is delivered to the right people who paid for it. Okay, so to give a short recap, what we have seen today is we have seen what typically a DevOps team does, what is their power, how they maintain their tech stack, where they have an influence on the engineering teams, what do they ask the engineering teams to do, when do they want the engineering teams to do, and how they want to do is something will be under their control. They have access to all possible tools which is typically used by almost all the teams, starting from product, engineering, QA, maintenance team, implementation, and support. And you help them become productive and deliver right product. And we also seen that there are, at a very high level, they help in maintaining versioning, they help you do continuous integration and delivery, they help you do observability at a very large scale. So in coming 5 minutes, I'll just run through what are the job roles people will have when you opt for a DevOps career. Okay. So when you join as a DevOps resource one, your typical entry level career would be DevOps resource one, where you take care of accesses, errors of the tool, you take care of version control, you take care of continuous integration, continuous delivery, you do all the bookkeeping. You write scripts in Python, you write scripts in Bash, you write scripts in small JavaScript files to verify whether the files are as per the complaints. Are people writing code as per the logic? Is version control working fine? Are there any merge issues, or are there any commit issues? Is continuing integration is working fine? Are people delivering as per the schedule? Are they deploying as per the release calendar? You typically do all these activities as a DevOps resource one. Okay. Then if you get promoted, you will become typically a DevOps resource two, or a lead who take care of three or more teams. Like you take care of PM only, you take care of engineering only as a DevOps one, but as a lead you take care of the entire company, and you actually look at where is what is where, who is doing what, and you maintain the metrics to see whether people are doing good or not by a technique or a metric called DORA. Okay, there are metrics called DORA. We'll look at what DORA metrics tomorrow. But these are some metrics Like how you have your semester CGPA to check whether you are doing good job after one semester worth of teaching and examination. Similarly, DevOps team computes some metrics week on week, month on month to check whether the product management team is compliant, engineering is compliant, all the teams are compliant. So these are typical DORA metrics. Okay, we'll go through what they are. After that, you typically become a DevOps manager or a DevOps architect. Okay, why an architect? Architect is a guy who will design how the rules of the DevOps teams are to be played. Okay, there could be a team size of 5. The rules for the team size of 5 might be different compared to a team size of 100. There are teams whose size is in thousands, who share input output among each other. Now, an architect is the guy who will define how a 5 member team needs to behave, how a 100 member team needs to behave, how a 1,000 member team needs to follow the rules. So, all the rule definitions, compliance definitions are defined and designed by the architect. So, these people, when when you typically have mergers and acquisitions, right? When one company purchases another company, these people, DevOps people, are typical people. Like an architect defines the rules, how to merge their source code with our source code, how the CI/CD approach of their company needs to be merged with our company, how the bug release policy, bug fixing policy needs to be standardized between the merger companies. So all these rules are typically defined by architects. Okay. So if you look at, you may start from DevOps 1 to lead, manager, and architect, and the leader. You can become uh, director, senior director, vice president, and the head of the DevOps. Okay. This is typical role set people. Today you can see in LinkedIn, you can search for DevOps roles, people in working in DevOps. This is what typically they do in the real world. Okay. So this brings us to the end of today's session. I've just touched a surface for you to give an intro on what DevOps is, what are the typical activities they do, why do we need them in first place, what happens if they are not present. All these items we have gone through. Maybe in tomorrow's session, we will eventually look at some ideas or some tools on how people do CI/CD, how people create release calendar, how people release the products. You might have seen some ads in YouTube which talk about Docker, Kubernetes. We will look at what those tools are in very short span, so that you'll get a rough idea of what DevOps is, and it helps you envision towards becoming a DevOps engineer in future. If you have any questions, please shoot them to Professor Vinay, or my email ID is anyway available to answer your questions. Or we can use the chat for 1 minute